Hello friends, welcome to Career Class Learning. Today we are going to discuss about microservices. This is a very important topic. If you are new to our channel, please subscribe to our channel for the great technical topics. Please share your thoughts in the comments. That will help us to create good quality videos. If you are looking for a job or any kind of interview preparation and resume building, please visit our website careerclass.com. All services at free of cost. Let's get started. What are microservices? Breaking monoliths into independent services. That means a microservice architecture is a software design approach where a large application is divided into small independent services and each service focuses on a specific business function. Instead of building one large application, that is monolithic application, you build multiple smaller services that communicate each other through APIs. Some characteristics of microservices are single responsibility. It means each service does one thing well, and independent deployment. So the microservices are having independent deployments. They are not depending on other services, deploy without affecting other services. And own database. It means each microservice should have its own database. API communication. So services talk via well defined APIs. So to make any communication between the microservices, they will communicate with API communications, which we will see into this one later. An architectural style that structures an application as a collection of small autonomous services modeled around a business domain. From monolith to microservices. So what are the challenges with monolithic application and what are the advantages of microservices? So in monolithic architecture, we will be having all together like a UI layer, business layer, data access layer, and a single database for all kinds of services, for all kinds of features, or we can call as for all kinds of modules like orders, payments, etc. Okay, all tightly coupled in one deployment unit. So in monolithic applications, all the services or all the features are in a tightly coupled deployment unit. In microservice architecture, so it will be having an independent service, independent module or independent feature that can be deployed without affecting any other feature in that ecosystem. So for example, we have authentication service, that is one microservice, order service, payment service, and notification service. So these are some examples of microservice. And in monolithic, all these four applications, all these four features are tightly coupled together and they can be deployed at a time. But in the microservice, these can be decoupled. They can deploy with their own database independently from other. These independent services communicate via APIs. So what are few advantages of microservices? They are independent scaling. So we have already learned on the scaling part what is vertical scaling and horizontal scaling. So if you want to learn, visit our video on the system design concepts. Okay, independent scaling and fault isolation. For example, if authentication service fails, that will not have any impact on other services. Or if order service fails, payment service and notification service will work as it is. So the fault is isolated. And technology diversity. So we can have a different technology for each microservice. So for example, one service can be having a Python, another one can be implemented in Java, and other service can be a Node application, and other service can be a .NET applications. To make a communication between among these services, we can establish a well-defined APIs. And another advantage of it is Team autonomy. Some core principles of microservices. They are loose coupling. It means services have minimal dependencies on each other. Changes in one service don't ripple across the system. So loose coupling means we discussed 4 different services in a previous slide. So they are not depending on each other. High cohesion. So related functionality is grouped together within a single service for clear boundaries. So if we have a monolithic application, it is having a combination of multiple modules. So we will keep all the similar functionalities or related functionalities into one microservice. For example, all the payment related calls or payment related functionalities will be kept in the payment microservice. And bounded context. So each service owns a specific business domain with its own ubiquitous language, DDD concept. So independent deployments. Services are deployed independently without coordinated releases across teams. So each and every microservice can be deployed independently. And decentralized data. Each service manages its own database. No shared data stores between services. So it is self-explanatory. So each microservice having its own database. So there is no shared database for these services. And smart endpoints. So business logic lives in services, not in the communication layer. Dump pipes and smart endpoints. So these principles enables teams to build, deploy, and scale services independently while maintaining systems integrity. So how microservices communicates? So there are 2 kinds of communication, synchronous and asynchronous. So in synchronous microservices, in synchronous communication, the request or response caller waits for a reply. It means, so the application sends a request and it waits for a reply, that is a response. So in synchronous communication, we use REST API. This is HTTP based request response. It is widely adopted. And gRPC, this is a binary protocol, high performance and contract first. It should have a contract established first. And GraphQL, this is flexible queries, client driven data fetching. So it is flexible when compared to with RESTful services. So for making a synchronous communication between the microservices, we use REST API, that is HTTP based, gRPC, that is binary protocol, and GraphQL, that is flexible queries. And if you want to have a asynchronous communication, so for asynchronous communication, it is fire and forget, decouple communication. So it will broadcast a message and it will wait for it will not wait for that one, and it is works as a subscription model. In asynchronous communication, we use message queues. In message queues, we use RabbitMQ, SQS, point-to-point messaging, and event streaming. For event streaming, we use Kafka Kinesis. This is pub sub at scale, publish and subscribe at scale, and event bus. So decoupled event-driven communication. So it works like service A, and in between message broker, then service B. So to make a communication between service A and service B, there is a message broker in the asynchronous communication. In async communication via message broker enables loose coupling and resilience. I hope you understand, right? So in microservices communication, we are having 2 kinds of communication. One is synchronous communication and another one is asynchronous communication. In synchronous communication, we are having REST API calls, gRPC and GraphQL, and asynchronous communication, we have message queues, event streaming, and event bus. Some key patterns with microservices. The first one is API gateway. The API gateway pattern, which is a single point for the clients. So single entry point that routes request to appropriate services and handles cross-cutting concerns. So the benefits of API gateway are authentication, routing, rate limiting, and logging. Some popular gateways are OSLOT and Kong gateway. And another one is circuit breaker. What is a circuit breaker? Prevents cascading failures by stopping calls to failing services and providing fallback responses. And saga pattern. So manage distributed transactions through a sequence of local transactions with compensation actions. We will discuss these topics one by one in the future videos, but this is a quick revision here. And service discovery. Service discovery is automatically detects network locations of services, instances for dynamic routing, console, and Eureka. And event sourcing stores state changes as a sequence of events rather than current states, enabling full audit trails. And sidecar pattern, this is another pattern, deploys helper components alongside services for cross-cutting concerns like logging and monitoring. Yeah, these are few services which we use in microservices architecture. These patterns solves common challenges in distributed systems. Choose based on your specific requirements. So we can discuss all these patterns in the future videos and their advantages and disadvantages and when to use them and which scenario we need to use which pattern. And data management. So how data management is used in microservices? So the first one is database per service. It means each microservice owns its private database, no direct access from other services, loose coupling, independent scaling, and eventual consistency. Services sync data asynchronously. System becomes consistent over time, not immediately. So high availability and better performance will be achieved with eventual consistency. And saga pattern. This is another one for the data management. So orchestrates distributed transactions as a sequence of local transactions with compensations. So it achieves no distributed lock and reliable rollback. Another one is CQRS, separates read, that is query, and write, that is command models, for optimized performance at scale. So it achieves scalable reads and optimized writes. Some polyglot persistence, that is write DB for the job. So these are few databases which are widely used for microservices, that is PostgreSQL, this is a relational database, and MongoDB, this is NoSQL, that uses a document based data, and Redis Cache, that is key value pair cache, and Cassandra, that is wide column database. Some challenges or trade-offs with the microservices. So what are the challenges with microservices? The one is distributed system complexity. So microservices are very powerful but introduce some complexity. How? In distributed system complexity, services communicate over a network, and problem is sometimes there will be a network failure and latency and timeouts. And network latency, some caching, asynchronous communication, and gRPC, data inconsistency. To achieve data inconsistency, and that is a challenge, and we can achieve with this one with saga pattern and eventual consistency and CQRS. And operational overhead. So for microservices, we are achieving it with Kubernetes and CI/CD automations, and monitoring and logging, debugging difficulty, distributed tracing, that is difficulty, and testing complexity, the contact testing we use, and security surfaces, the zero trust, MTLS, API gateway path, and monitoring at a scale. So in monitoring and logging, tracking a request across multiple services harder. So where it is going wrong is identified, and to identify the where the issue comes. So it is somewhat a difficult process to identify in multiple microservices, and the deployment complexity is another one. So you may have dozens of hundreds of services. Some common solution is uh, Docker and Kubernetes. So microservices aren't always the answer. Start monolithic, extract services when complexity demands it. Some technology stack. So to achieve the microservices, there is some technology suggested technology stack. For containerization, we use Docker's Pod1. Docker is a container runtime and packaging, and Pod1 is a daemonless container engine. For orchestration, we use Kubernetes. Kubernetes is a container orchestration platform, and Docker Swarm, native Docker clustering. And for messaging, we use Apache Kafka, that is event streaming platform, and RabbitMQ for message broker. And some framework are Spring Boot. This is for Java-based microservices framework, and Express and Nest.js, that is Node.js framework, and service mesh, that is SEO, traffic management and security, and linkage, lightweight service mesh. For monitoring, we use Prometheus, that is for metrics collection and alerting, and Grafana, that is visualization and dashboard. Okay, here choose tools based on your team expertise and scale requirements. There is no one size fits all the stacks. So let's discuss about what are the advantages and when should you use microservices and when you avoid microservices. There are few scenarios you should go for the microservices. So if it is a large application and multiple teams are available and independent deployments required and high scalability needed and long-term enterprise products. So these are some scenarios you can go with a microservice, and that will help you with a diverse team members and diverse with a different technologies. And I avoid microservices when if it is a very small application and if the team is having very less developers, if it is a small team of 1 to 5 members and a startup MVP, it means so to create some initial MVP, please avoid microservice and simple CRUD applications. So for simple CRUD applications, there is no need of maintaining any microservice. Simply, the short answer for the microservices: a microservice is an architectural style where an application is divided into small, independently deployable services, each responsible for a specific business capability and communicating through APIs or messaging systems. This improves scalability, maintainability, fault isolation, and deployment flexibility. I hope you understand what is a microservice and you understand how to make a communication between microservice, what are the advantages, and when to use a microservice, when to avoid the microservice. Thank you for watching. Please like, share, and subscribe.